Find the center of mass of a thin plate bounded by x over 2 and the square root of x from 0 to 1 with uniform density. And so we're going to ignore delta. First, we sketch the graph f of x when x equals 1, y equals 1. And g of x, g of 0 equals 0, g of 1 equals 1/2. Is it bounded from 0 to 1? So we only look at the thin plate in the shaded region. Again, the density is uniform, so we're going to ignore delta. And so to use the x bar and y bar formula above, we're going to find A, the area, the moment about the y, and the moment about the x-axis. The area, the integral from a to b, f of x minus g of x dx. The upper curve is the square root of x, and the lower curve is 1/2 x. The integral goes from 0 to 1. If we integrate this, we will get 5 over 12. The moment about the y-axis is the integral from a to b x times f of x minus g of x dx. So that is the integral from 0 to 1, x times square root of x minus 1/2 x. Multiply x out, we have the integral from 0 to 1, x to the 3/2 minus 1/2 x squared dx. Integrate this, we will get 7 over 30. The moment about the x-axis is the integral from a to b, 1/2 f of x squared minus g of x squared dx. That is the integral from 0 to 1, 1/2 the square root of x squared minus 1/2 x squared dx. Simplifying this, we have the integral from 0 to 1, 1/2 the square root of x squared is x, 1/2 x squared is 1/4 x squared, then dx. Evaluate this integral, we will get 5 over 24. And so x bar equals the moment about the y-axis, which is 7 over 30, divided by the area, which is 5 over 12. So 7 over 30 divided by 5 over 12. Simplifying this to get 14 over 25, which is 0.56. Y bar equals the moment about the x-axis, which is 5 over 24, divided by the area, 5 over 12. Simplifying this to get 1/2 or 0.5. So go back to the graph. We see that x bar is 0.56, a little bit more than 0.5, and y bar is exactly 0.5. That's the center of mass. Now, with the same problem, but if the density is not uniform, in this case, the density is a function of x, and so it is not a constant, and so we cannot ignore it. Well, this time, x bar equals the moment about the y-axis divided by the total mass, and y bar is the moment about the x-axis divided by the total mass, not my over the area, not mx over the area, because the density is not a constant. So when we evaluate the integral to find the total mass, we would have to replace density delta with x squared. X bar is my over the mass, so we would need to have delta being x squared in the integram.